Welcome everyone to our Friday presentations. The title of my talk is Ayo, check out my mixtape. It's Supa Hot, Google, Python, Fire. So I do know how to spell, but this is just kind of a play on words for those of you who know who Supa Hot Fire is on YouTube. I don't have any cool bars to spit for you today, only some fire demonstrations, hopefully. So yeah, let's jump into this. As always, I'm going to introduce myself for those of you who may not know me. My name is Griffin Higgins. I'm a PhD student and cybersecurity software developer here at the Canadian Institute for Cybersecurity. And a fun fact about myself is that I love nerdy things. At the very bottom, you can see my 2014 MacBook Air, which is a little side project I have, still keeping it alive. And I'm just going to run this poor little thing into the ground. That's kind of my plan. So what are we going to be doing today? In terms of an agenda, I'm obviously going to give the introduction I'm giving right now. And then let's just see kind of where things go. But first, I want to ask you a favor. I want you to think back to when you were first learning to program. And maybe during this time, it was a happier time in your life where there was sunshine and rainbows. No, I'm seeing some nods, but for those of you who did enjoy this, it was a great time. And it was a great time because we did very, very simple things. We didn't have to deal with, adversarial deep learning or quantum cryptography or any of these crazy kind of complex things. We only had to deal with three very simple things. We only had to deal with standard input, standard output, and standard arguments. Text in, text out, and maybe a couple little things that we could sprinkle in to make it do some other things that we were interested in. But what might these look like? We can say these terms, but what do they look like in code? Well, simply put, we can see when we say input, we might see your name, and you might literally type in your name at the command line. We might also recognize standard out when we say print hello world. That's going to be text that comes back to us from our programs. And we might also recognize the standard arguments in terms of the first positional argument at index 0. We might check to see if it's -v so that we can do something conditionally later. So even though we talk about the standard in and standard out and all this stuff, today we're going to be mainly focusing on the standard arguments. And generally speaking, they're important to us because they help us define program behavior, like on the fly. So we don't have to manually go into our program and open it up and change all the loops and the conditions. We can just specify a little flag while we're running it and make it presumably do something completely different. So what might this look like on the command line? How does this all work? Well, if we recognize that there might be various kinds of programs, if we're dealing with a Unix operating system, for example, we might have a program called foo, and we might give foo a standard argument. So file.txt would be a standard argument to foo. We might also see that there's this kind of separator in between, which is called a pipe, and it would allow other programs to accept the standard input of the standard output of other programs. So essentially, it just means that we can start chaining these things together, and that one program doesn't necessarily need to know how the other program works in order to do complex things together. So we might ask, what is -v? Well, if we think about this a little bit, we might open our MacBook up and we might actually go look at some documentation. And when we look at the documentation, if we open up the manual page for it, we might go down and say, oh, -v. And then if we look, we might also see it has this longer version which says invert match. And if we dig into the documentation even more, we can see that rep has this thing called a synopsis. And how we read a synopsis is we can see that anything that's surrounded by the square brackets is going to be optional. So optionally we can include -v, but optionally we can include -a or -d. Additionally, there's other command line arguments we can specify, like the color, and we might actually set this to a real variable. So it's not just that things might have the existence of a flag or a particular argument, they might also have sub-arguments behind them as well. So how might we do this in creation of one of our own programs? Well, perhaps in Java. I'm sorry, we're not doing this here today, just kidding. Let's do it in Python because that's a common language that we all use almost on a daily basis to get things done. It's not here for speed, it never claimed to be fast, it just works and it gets the job done. So to do this, you might just say, like, that's easy. just use sysargv, like some of the things we previously talked about. And while that's a very good idea, I encourage you to pursue this hypothesis and test it out on anything complex. And when you do this, you're going to find out that that little question mark was supposed to be a hand. I guess the emoji didn't transfer right. You're going to find out that it's just like touching the hot stove. You're going to think that this is going to be a really great idea, but there's a lot of complexity behind all the different arguments and how they can be arranged and what might be behind them, and just too many things for you to consider if you were just going to type it out and program it yourself. So, don't you know about this thing called argparse? And if you're familiar with Python, you would know that this is a library built right into the standard library to allow you to do this very thing. And I actually do know about argparse, and it actually has some very, very good benefits for us as programmers. So first and foremost, it's part of the standard library, which just means that we don't have to pip install anything, and that it will always be there for us on any machine we just open up on day 0. So that's a very, very strong motivation, and it's one that's never going to go away. Another motivation is that argparse is very, very clear for others. So if you ever go to look at a GitHub repo and you see all the flags and how they're specified, you can have a very, very good intuitive understanding of what's happening. Optionally, argparse can be very, 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 very verbose. So you can put as much detail into it as you want, which is good if people that don't really know what they're doing are trying to run your programs. You want to make sure that that's very well defined so that they don't just hit a bunch of walls and have their programs explode in their face. And this is fantastic. This is fantastic as a final deliverable when you actually want to give this to real people in the real world. Double thumbs up from me. But where this kind of falls flat on its face is when we want to do development in kind of a novel context that needs something to be highly flexible, and if you're trying to do very high dimensional things, right? This just doesn't work if you're trying to be verbose and you have one more thing to keep track of and just make your life miserable. So, but again, still a very big plus is that it is part of the standard library, so it will be there. But now let's say, okay, what's your bright idea then, smarty pants? You've taken out kind of the 2 things that I already have at my disposal. What better things do you have to offer me? Well, I would be glad that you asked. And I would also kindly direct you to what we're going to be talking about today. So this is Python Fire. It's created by Google in about 2018, I believe. And I want to ask if anyone wants to take a jab at what's the most important part of this slide? Anyone want to take a guess? Automatically? Automagically? That's a very good one, yes. Any others? Okay, CLI? Yeah. So I'll make it really easy for you. Make it really easy. There's 27.1 thousand people out there that have starred this repository. Okay? For reference, that's almost 170 times more than CIC's most starred popular repository for a flag parser. Okay? This is mind-blowing. Like this library isn't doing anything that we would classically deem to be important, and yet it has such popularity and people love this thing. What's going on? And you might also say, after this statement, after this conclusion, whose side are you really on here, Griff? What are you trying to say? Are you trying to say that we're not as good as this flag parsing library? And that's not at all what I'm trying to say. Again, all I'm trying to do is point out that this very unimportant library, this very unassuming library, might actually have something very important to tell us, but only if we're here to listen to it. So with that being said, I would love to jump into a demo of what this Python Fire thing is and how it works. So just to start off, I'm also going to go to my GitHub. If people want to follow along with this talk, I've put up all the code in the various different places that we're going to be covering here today. And it's a very simple demonstration. But again, there's also a guide that we reference directly from Google that helps us understand what's going on. So with that being said, let's jump into the demo. So I have this organized in a very particular way. Normally I like to have code like big font so that everyone can always read it. But when we're doing live demonstrations, sometimes that's not always possible. So if you have any questions after the talk, please let me know. But essentially how this is organized is at the very top we have 3 different files. So we're going to have the example from sysargv library, we're going to have the example from the argparse library, and then finally we're going to have the example from the fire library. On the very bottom, we're going to have an example of how we might actually run this at the command line, and then we're also just going to have a terminal so that we can see what the output of this is going to be. We can also see that when we look at the standard the system library, we can see that basically all it's going to do is import the system library. It's going to define a very simple function, and then it's going to get the first positional argument, pass it to our function just called hello, and then it's going to print it. I've also shown this in the argparse library here, and we can kind of see that the code starts to expand a little bit, and that it becomes a little more verbose. And then on the very far side, we can see a fire library, and importantly, we also see that it's not really accepting any arguments anywhere, which is kind of strange. And it's also not accepting like a print statement. So what is going on? And we're going to answer some of these questions in a moment. But when we go to run this on the command line, and we have like the system library, if we have the argparse library and the fire library, and we all pass them the same argument, what happens here? Well, as we might expect, we're just going to get the same thing. So it's just going to print hello Griffin 3 times. It's going to be the same output, but using different libraries. So we might be saying, okay, well, you know, this doesn't really seem that helpful right now. I can get by just with this with the system library. But what about if we have something a little more complex? Let's just ramp up the complexity just a little bit more. It's kind of hard to see. I guess we don't need this. But if we look at the very first library, all we're going to do now is try and accept 3 arguments. So we're going to accept a first name, we're going to accept a last name, and then we're going to accept a third argument, which is going to allow us to uppercase everything in the final printout. We're actually not going to do this with the system library because we start to understand that there's a lot of things we have to control. So if we want to pass this first name or last name, we need to think, oh, is it going to be -f or is it going to be -- first? And then, you know, what if it's not there? And then what if the argument after this flag isn't there? And then what if it's in a different spot? Like there's too many things that start to ramp up in this thing that we would all just take for granted. And we're actually not even going to try and run this. So we can say goodbye to that. When we look at the argparse library, we can see that we can start to define some of these flags. So we can see the -f and the -first, and we can say what kind of data type we want it to be. But interestingly, when we look at the Fire Python library, there isn't any of this code to define what all these arguments are. They're actually kept as part of the function arguments. So we can see up here, we define first is going to be equal to John, last is going to be equal to Doe, and then upper is going to be false. Also, when we go to run these in our terminal, we can see that there's lots of different arguments. So we can see we can specify first and last. We can specify with the uppercase flag. We can also specify them with -l instead of last. So there's lots of different combinations that we can try. And again, if we run this in our terminal, we can see that it will print out the same thing for both of them. So it just has some slightly different arguments applied if we're doing the uppercase or the lowercase. But something I want you to take away is that here, we didn't actually have to go and define this giant flag parser. All we did was import this tiny little library. We just imported Fire, and then boom, it was done. We didn't have to do any extra work. So this is really, really attractive if we're trying to work in this very flexible, research-oriented space where we're trying to rapidly develop and prototype things. We don't want to be typing out flags all day. We just want to import this library and go about our life to do other more important things. So okay, what else is on the docket? So we've talked a little bit about all the automatic flag parsing and argument parsing that can happen, but how does Python actually know what this is? Because typically when we accept arguments, we just assume they're all going to be strings, right? But interestingly, if we create a function and we accept the first object that comes in, we get its type, and then we print out the type or the name of its type, and we pass this to Fire, and we run it a bunch of times in our examples where we might pass in an integer, we might pass in a floating point number, a string. Interestingly, we can start to pass in Python objects like tuples and lists and booleans and even dictionaries, which gets a little crazy. We can see that if we try to run this, Fire is actually going to figure out that, hey, like this is what this data type is. So it knows automatically without you having to do anything that, hey, this is a dictionary. And you can just use that in your program and go about your life. So it's really good. And I don't think you can even start to begin to do those things in other libraries, definitely not the sysargv library or the argparse library. So that's a little bit on the data types. We can keep going on, and we can also start to play around with functions themselves. So in the previous slides, we were inputting a component to Fire when we called it from our main method. But if we don't give it any kind of component, Fire is going to look at the environment and see all the different functions that are defined, and then just give it to us to run on the command line. So for example, if we define an add method that takes in an x and a y, and we also define a multiply method that takes in an x and a y, if we're on the command line, we can literally just say add 10 and 20 or multiply 10 and 20. So if we run this, interestingly, we can see that it outputs 30 and 200 and 200. So that's pretty cool. It means that you again don't need to have all this crazy flag parsing logic figured out, and you can write programs that are going to be quite flexible for you on the fly as you're trying to do research. So this is interesting, but what else can we do? It keeps getting crazier. What if we wanted to do this with a class? What if we had a calculator class? So here, if we have this class and we have the same methods defined, add and multiply, we can actually import this calculator into Fire. And interestingly, it's actually going to give us the same things. So I'm just going to comment the intermediate examples here. Yeah, let's comment these out. Let's comment the advanced examples out. So yeah, so interestingly, when we run this now, we can see that we're starting to work with classes just from the command line. And we didn't have to do, again, any flag parsing logic, and it's just something that we could just grab right out and start working with. We can also start to ramp this up a little bit. So what if we had a calculator, but what if we also had a broken calculator? What if we had a calculator that just by default added 1 to whatever we wanted to add to it? So if we did that and we ran it, we would see that it would give us not good results. So let's try that now. If we run add and multiply, the same things, we can see that it will give us 31 and 201, and those are not the answers we're looking for. But if we specify an offset to our calculator, we can actually correct this. So again, we didn't have to open up the program, we didn't have to go change anything. This is just something we're doing on the fly. So if we run this now, we can see that we start to get correct answers. Instead of 31, we get 30. Instead of 201, we get 200. So that's awesome. What about even more advanced examples? What if we had multiple classes and we wanted to make a pipeline of things that work together? Well, we can do this. So if we have a class that just says it's the ingestion stage, and then we have a class that says the digestion stage, and we have a class called pipeline that merges both of these things, what happens if we just give pipeline to Fire? Well, when we do this, we can start to see that we can call the different things as part of its classes. So we can say Python just run, so it'd be run this method of ingestion and digestion. We can just run the digestion if we want, as well as any of those subcommands from the classes. So again, this isn't for you to be overwhelmed with all of these classes and functions and stuff. It's just for you to appreciate that this library, this small little flag parsing library that we'd probably just like shoo off, is actually going to do a lot of things for us with almost no cost to us at all. So if we did want to run this advanced example, we can do that. And we can see that we can start executing various parts of our pipeline arbitrarily. So if my supervisor comes to me tomorrow and says, only do this part, or only do that part, or merge them together and have this tiny flag do this arbitrary thing, it's not a problem for me. I can do it in like 5 minutes instead of trying to sit there for an hour and change the flag logic and all these things. So okay, what else can we do? I keep saying this, but we can also start to work with different kind of function calls and APIs. So if we have an airport, for example, and we have another class that defines out how to get a name or a code from a given code, we can start to chain different things together. Let me just comment this out too. Great. Let's just run it really quick. So we can just start to see that from this Python example, we can input JFK as our argument to this program, and then we can also tell it what we want back. So do we want the code JFK? It'll give us JFK. Do we want the name to this particular code? It'll give us the full-on name, so San Jose, Santa Clara. Or if we want to look at other things, we can get the city of where that thing is from. So again, it builds in this kind of flexibility. Interestingly, I only learned this morning. We can start to add in other kind of Python methods. So if we recognize that what we're getting back from the output of all of this is a string, we can start to call like string methods on the things that are returned. And the way that you read this is you say, okay, I want to give this code argument to example.py. I then want to get the city from this thing back, which is going to be a string, and then I want to uppercase it. So again, arbitrarily, we can put any kind of Python string here. If we run it, we can see that we're now going to get this uppercased. There's other examples, but I also want to make sure that I'm in time. So we're going to keep moving. Another thing that you might be very well familiar with in Python is var args and quargs, or variable arguments and keyword arguments. So here, if we have some kind of function, we can understand that the first argument is going to accept whatever that first thing is going to be as input to the function, and then the star args will accept however many other variable arguments that there will be as input to the function. We can also, after this, define the first keyword argument being b, as well as any other keyword arguments that might get trapped in this function. So if we were to call this from the command line, we could actually call this thing that's called Python example.py, and we could call foo, and foo will be assigned to a in this function, and then we could call boo, so we're going to call foo, which is going to be the function, then we're going to say boo, which is going to be assigned to a, which is going to be the first thing. We could call moo, 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 and that's going to be assigned to the star arguments. And then if we wanted to, we could say dash dash var, it's going to be baz. And I know this is just this is sounding just absolutely crazy at this point, but if we run this, I'm going to comment this part out too. But if we run this, we can start to say that we get foo, and then we can access boo, and we can access 10, and we can access all the arguments, and we can access all these keyword arguments. And I don't know about you, but if I had to write this all out in sys from the system library, I'd probably go crazy. It'd probably take me a couple hours, because there's so many complex things and edge cases that it'd be almost impossible to figure it out. So again, I'm going to make sure that how much time do I have left, Wendy? Going way over?
3 minutes.
Okay, cool, yeah. So I'm going to keep moving, and the other things I'm going to say are just that we can also accept separators. I'm going to skip over this because it's not as important. We can also build in documentation. There's other flags to fire. So for example, all our doc strings at the top of our functions aren't just going to go to waste anymore. So this is amazing if we call after our arguments are done, we have a double dash, and then we say dash dash help. We can take a look at all of the documentation that's automatically generated as part of our program. So now we can see, okay, what's the name of my program? It's example.py. What's the synopsis? How can I actually run this? It gives you the group and the command. What are some of the arguments, and what are some of the descriptions for the functions, right? We can see foo, we can see bar, and we can have the descriptions for what they might do. And again, all of this is happening automatically. You don't have to do anything. It's just done for you. So if we keep moving, we can actually see that's the end of the demonstrations, and we can go back to our slides. So in the last 2 minutes, what are the very high level takeaways from this flag parsing library? One is that it just solves the problem, right? At no point did I have to sit down and write out a bunch of flags. It was just done. 2, it gets out of the way. It's not messy. I think it was about 3 lines of code total to have this fire library import and do a bunch of stuff. And 3, it just doesn't add a lot of overhead. So all the cognitive thinking that I would have had to do to think about the flags, it's already a part of the function signature. It's already part of the class signature. Just use it where it is, right? And then with that, I would also cite some other honorable mentions for Python-based CLI libraries like Click and Typer, and there's a lot more at this GitHub repository if you would like to check it out. But with that, I would say thank you so much for listening, and I hope you enjoyed my talk, and try out Fire.
Thank you very much. Any questions for Griffin? Yeah.
So how big is this library? Do you know? The file library?
I would say it's probably pretty small. Maybe under like 10,000 lines is what I would just guess. But
Do you have access to the source code?
yeah, absolutely. It's open source, so that's a very good question. We can also go take a peek at Fire. It's in Google's repository, so it's pretty good.
You can go and change it and adapt it as you want.
Absolutely, yeah. You can go in and fork this and do whatever you'd like. Yeah. So that's a great question.
Any other questions?
The only thing I would just add is that this isn't part of the standard library. So if you just go and write a Python program and you put Fire at the top and you expect it to work, it's going to blow up. It is the big drawback to Fire, but just pip install it. Takes you like 2 seconds, and then you'll be home free.
Yeah, I'm sure they will have more questions once they
Yeah.
try it out. Yeah.
Absolutely.
Thank you very much.
Thank you.